So first I'll talk about operators. Operators in the sense, uh, like for example, let's talk about arithmetic operators, right? So basically, what are arithmetic operators? Operators that perform the mathematical operations, like for example, addition, subtraction, multiplication, division, and all, right? So in Java, we have all these arithmetic operations, like say for example, uh, if you want to perform an addition, right? Like, let me go to my Hello or Java class. So you can do int you have two variables, int a equal to 10 and b equal to 20. Right, and you created an integer variable which will hold the sum of these two numbers. So to do this mathematical operation, your Java definitely supports the arithmetic operations, right? So when you say a plus, so I can say sum equal to a plus b. Okay. Then I'm printing the sum. Sum of a and b. I'm running here. What happened? Okay, it's SQM. See, I gave capital S, so that's it's giving me an error. Okay, sum of A and B is 30, right? So it basically supports all the mathematical operations like addition, subtraction, right? Subtraction, obviously it's minus, and we perform multiplication using the asterisk symbol, asterisk operator, right? You see 10 into 2200, and then division by this A by B. It will give you the quotient, and then reminder, you put the percent symbol, right? So likewise, you have different operators. You know, we have different operators when we work with Java programming, right? Different arithmetic operations. So that, I mean, it's straightforward. There is nothing much in it, right? But one thing we need to remember is when it, suppose let's take, I'll give you an example of one typical mathematical expression, then we will see how it basically evaluates, right? So let me write something here, and I'll say a plus b into 2 plus a. I'll take another number, probably c, right? Equal to 5. Can someone tell me what is the output of this particular expression? Guys, can someone tell me what is the
300.
output of this expression? 300.
Yeah.
Okay. Who is that? 300?
55. 55.
1 second, guys. Yeah. Who said 300? Amrita, okay. What is the next answer? Someone said something, right?
55.
55. Sorry, come again, guys. I couldn't hear you properly. Repeat it again.
Yes, 55.
55. Okay. Someone said 55. Okay. And what else?
I think it's 65.
65, 55, 300. Any other answers?
210. 210.
210. Okay. Okay. Any other answers? Okay. 55, 65, 210, and 300. Okay, fine. Let's see what is that? What is the answer? 55, right? Why? I think someone said 55. Can you guys tell why?
Yeah,
Why not 65 or 210? Or...
Because the d into 2, first of all, we have to do the BODMAS rule, 20 into 40, and we have to add a plus c. It's 55.
Right, that's right, exactly. I think who is that? Who told me? Raj. Okay, thank you, Raj, for that. Yeah, right. So in mathematics, you have a BODMAS rule, right? So the same applies in Java also. In Java, we call it as operator precedence. Okay. So when we have a typical mathematical expression like this, right? So which will execute first, right? So which operator will execute first, right? So there is that thing always, right? Because if you don't follow certain rule, every time you evaluate this expression, there might be some unpredictable answers, right? Like first time it will do b into 2, right? Or probably it will do 2 plus c first, or it will execute a plus b first. So if there is no certain way we handle this, every time this expression is evaluated, it may produce unpredictable outcomes, right? So which is not expected, which is not the way it should be, right? So how do we kind of deal with this, right? So in Java, you have something called operator precedence, which is nothing but it basically tells, suppose in a single mathematical expression, if you have multiple operators, right? And which operator would execute first is what called as the operator precedence, right? So in this particular example, like similarly how you have this BODMAS rule in mathematics, the first precedence in a given mathematical expression would always be multiplication. Okay, so this one, b into 2, and then you have then comes the addition, no, then this division will happen. Okay, as per Java's operator precedence, first multiplication, then this division. Okay, these two things will come, then addition, then subtraction. Okay, and you have multiple operators. Okay, this is the basically operator precedence. So if in a given expression, if you have multiple mathematical statements, first this multiplication will happen, then if any division is there, that will happen, and in the end it will be plus or minus, right? Now having said that, I'll change this to, now can you guys tell the output of this particular statement?
53.
53. Okay.
52.
52. Any other answers? Okay, let's execute this.
52.
52, right? Because first this will be executed and then this will be executed, and in the end everything will be added as per the operator precedence, right? It's not like first this will get executed and then this will get executed and then in the end everything will be divided by 2. That's not the case. It will not happen sequentially like that, right? It goes as per operator precedence. So to avoid the confusion, right, whenever you write any mathematical expressions like this, it try to put the parenthesis like this. Okay, understood, right? So this will clearly, when you write this, you don't have any confusion now, right? A is 10, next B into 2 together, right? It's not like A plus B first and then into 2. It's not like that, right? If you this is the, let's just see that putting the parenthesis will actually influence this order. It is into 2, right? Now let me just change this parenthesis and let me just put it this way. Now B into 2 will happen first. It will happen or it won't. It won't happen, right? It will be A plus B first because of the parenthesis. Parenthesis increases the operator precedence. But even though it happens in this way, but parenthesis override that. So first A plus B happens. So 10 plus 20, which is 30 into 2, 6 and 2, which is 62, right? So this is the output. And similarly, using parenthesis, you can change this behavior completely. Okay. Now you have this. Now what will happen? This is 30 and this is 2 plus C by 2 will execute first, which is 2, and then 2 plus 2, 4. So 30 into 4, 120 will be the output. Okay. So putting parenthesis will also change the how your operators execute in a, which operator will execute first in a given mathematical expression. Okay. Understood, guys? Any queries here? Is this clear or any queries, guys?
Okay.
Okay. So just keep that in mind. Okay, when you work with these arithmetic operators, you would have to deal with this thing. So it's better always when you write your mathematical expressions, always try to put them in a parenthesis. Okay, and having said that, there are two more operators that you may not come across typically, right? So you have something called post increment and pre-increment operators, like postfix and prefix operators. Like say, for example, I'll say A plus plus. So this is nothing but it is equal to A plus 1. Okay, the same expression. Okay, A equal to A plus 1 can be written as A plus plus. So it will just increment the value of A by 1. Okay, A plus plus. This is called prefix operator. So let's just see that. I'll do A plus plus and then I'll try to print A. Okay, it is 11 as expected, right? So this is basically a postfix operator. Suppose if I use a prefix operator like this, A plus plus. Okay, I'll just comment this. You see this? Okay, this is 11, but this should not give us 11.
I think it's 12.
Sorry? Come again? Yeah, you're saying something, right? What is it, guys?
It's 11.
Okay. So using plus plus, this is equal to a equal to a plus 1, and you have a various operators like this, right? This is a pre-increment, and similarly you can also use a minus minus, which is typically equal to a equal to a minus 1, and you also have a plus equal to 2, which means a equal to a plus 2. Okay, so you have a various set of operators like this. Okay, so like I said, but given in any right, any arithmetic operator that you have, when it is basically used in a mathematical expression, it would like when we talk about operator precedence, right, where this plus plus would stand. Suppose I'll just go back to the previous expression here. So suppose I said plus plus a. So now how this mathematical expression will evaluate? Which operator will execute first, right? So in the same scenario where plus plus precedence would fall, it would fall after the end, somewhere in the middle or at the start, right? So this prefix and postfix operators, they execute first, and then only multiplication will happen. Okay, so as per Java arithmetic operators precedence, if you take, first will be your post increment, plus plus and or pre-increment operators, plus plus minus minus will execute first, then only multiplication will come, and after that your division, subtraction and all, right? Addition, division, subtraction and all. So this is what it is. Any questions, guys, here at this moment?
No questions.
Okay. So having said that, but let us just try to understand this a bit more, right? Just give me, like say in the same example, I'll just remove everything. I'll give you a bit more understanding of this prefix and postfix operators. Okay. So here I'll say I'll take another number, probably something like C and D. So in C, I will assign plus plus B. And in D, I will assign A plus plus. And then I will do C plus plus. Okay. So let's just try to print this out. Now just think through what the output for this. Can you guys think through and tell me? I want to give you an understanding of the pre-increment and post-increment operators. Okay, they are pretty important because you use them in loop quite a lot. So it's good it's important you understand the differences between. Yeah.
Number 14 is going to print 10.
Okay, output 10.
Okay. Okay, number 15 It's going to print 20.
20. Okay.
Okay, number 16 is going to print, I think 22.
22. Okay.
And number 17, D plus, I think is 11.
11. Okay. Okay. Anyone has any other answers?
Yeah, I have number 1 is 11.
Number?
Number 1 is 11.
Number 1 is 11. Okay.
Yeah, number 2 is 21. Number 3 is 22.
22. And last
Yeah.
one?
And number 4 is 10.
Okay, interesting. Any other answers, guys? Okay. Let's just execute this. Any other answers? Or I think most of you agree with these two.
Give me the
Hello? Guys, if someone is not speaking, please go on mute. Okay. Yeah. Any other answers, guys, apart from these two? Or do you all agree among these two answers? Let's just see that then. Okay. So I'm executing it. 11, 21, 22, 10. So who gave me this answer is it's correct, right? The second option. This is not correct if you see. So why is that? Right? So let's just try to understand this. Just take a moment, look at the output. Right? I'm giving you a minute, just sync in the output and just see, then I'll explain why it is coming that way. Who gave me this answer?
I did.
Sorry, your name?
Oh, sorry,
Alex. Okay, thank you, Alex. Yeah, that's right. Yeah, so this is the correct answer, right? So just look at it again and try to understand the difference between the prefix and the postfix notation. There is a subtle difference between both of them. The idea is both of them will increment the value by 1, right? But there is one small difference between both of them. Okay, so to understand first, right? So if you see on the line number 10 plus b, that means it is a prefix operator. So if you see here in prefix form, right, the operand is incremented before the value is being obtained for use in that particular expression, right? And similarly, if you look at line number 11, which is a postfix, here the value is retrieved first and then it's incremented, right? That's the only difference. Okay, just remember that the value is retrieved first and then it is incremented, right? So if you take the one first is a, right? A, what is the value that is being printed here? 11, right? It is because at expression at line number 11 here we are doing a plus plus, which is nothing but this is equivalent to what? D equal to, right? A plus 1. And at the same time, this is like this, right? D equal to A plus 1, something like this, right? Similar to this. Or we can put it, or you can, in the back end, what will happen, right? This is equivalent to these two steps. I'll just put it here. This will get executed first. A equal to A plus 1. Okay. And then D equal to A. So this is what D equal to A plus means. Okay. Similarly, C equal to plus D. What will happen here, right? So sorry. In this scenario, first statement will be okay. In case of prefix operator, right? Plus coming first before the value. So here, see here B, right? Value B we are doing first. So here B equal to B plus 1 will happen first, and then C equal to D will happen. Whereas in this case, D equal to A will happen first, and then A equal to A plus 1. And similarly, plus C plus plus is, in this scenario, you don't have anything prior to this, right? So C equal to C plus 1 simply. Okay. This is what will happen. Now, if you look at, see, in case of prefix operator, the increment is happening first and then assignment. Okay. So that's why if you see here, the B here, if you see the C value is nothing but B equal to B plus 1. B is 20, right? So B plus 1 is 21. So 21 is getting assigned to C here at this moment. Okay. And then coming to D, first D equal to A is getting evaluated. So here D value is becoming what? 10. Okay. And then A is getting incremented. So A is becoming 11 here. Okay. And then in the end, C is getting incremented by 1. So previously we knew C is 21. So C is becoming 22 here. So that's why if you see when you print A here, A is 11, and then B value is 20 since we didn't modify it anywhere, right? And then, yeah. So yeah, here it will be 21, which is getting modified here, right? B value, B equal to B plus 1. So B is 21 here, and then C value is 22, D value is 10. Okay, because D equal to, when you use postfix, right? First the assignment will happen and then the increment. This is the difference between prefix and postfix operators. Okay. Any question, guys? This slight difference happens only in case of mathematical expressions. Okay. Otherwise, you will not notice much difference between both of them. Okay. So that's with respect to arithmetic operators. Okay. Now let's talk about bitwise operators. So bitwise operators, these operators we can apply to, if you talk about bitwise operators, right? Say we have something like this, like say for example, tilde operator, right? Bitwise unary not tilde, like, which is basically present on your keyboard. If you have this exclamation mark right on top, like next to your 1 2 3, just before 1 you will have this tilde symbol, this symbol basically, right? This is a not operator. And then you have bitwise and operator. Okay. Bitwise R operator likewise. So that you have so many bitwise operators, exclusive or shift right, shift left, bitwise and bitwise or. So likewise, you have certain operators, right? So these bitwise operators, they basically act upon the individual bits of their operands. When I say that, so basically what data types we can apply these bitwise operators, right? So bitwise operators, we can apply them to long, int, byte, short, char, okay, not boolean. And similarly, arithmetic also you can't apply them to Boolean operator, but you can use them on the char, int, all these things you can use, but not on Boolean. So similarly, bitwise operators also you can't use them on Boolean, but you can use them on the integer like byte int short and the char data types, right? And coming to bit, right? So basically, bitwise operators, they work on the individual bits of an operand, right? When I say bits, you know, right? You have that octa format, which basically we represent these numbers, right? For example, value 128, which is stored in the 2 to the power of 0 to the power of in that format, right? Which we discussed in our last session. So you have bits like, otherwise the value 128 might be stored in the binary format, ones and zeros, right? So probably it will contain something like 11101111 something 8-bit notation, right? Like something like this. So if you talk about guys who are not speaking, please go on mute, right? So if you say a equal to 10, it might be represented in a bitwise operation like this, right? Like 1001 2 something, sorry, not 2, 110, 8 bits, right? So you have 8 bits here. So it would be represented in something like this. I'm just giving an example. It's not the exact. So bitwise operators basically work on this. Okay. So when I use the not operator like this, suppose if I say not a, what will happen is it's just a complement. Okay. It will change the values of bits to otherwise, like 1 will become 0 and 0 will become 1. Okay. So not a will complement the bits. So basically, bitwise operators, they work on, rather than, they don't work on the straight numbers, they work on their binary representations. They will apply these operators. Okay. So that's all. I just keep this in my mind. Keep this in mind. We're not going to discuss much about this. Okay. But you have something called left shift operator like this. You can use this. You can use this, right? So what this will do is, this will just shift this binary representation by one value. Like this is the original A, right? And complementing it, not A will give this representation, right? And when you do bitwise shift operator, it will just shift these digits by one, like one digit like this, 111, and in the end 0 will add. Okay, it will shift the left. It will shift this number to here, this number to here, this number to here, this number, and in the end 0 will come. Okay, this is the left shift operator, and you have a right shift operator also, which will shift the otherwise now. So now the number will be 0 0 0 0 111 0 0 111 0 0 0. Okay, this is the right shift operator, right shift. So likewise, you have certain bitwise operators which basically operate on the binary representation, 8-bit representation of that particular number. Just remember that. Okay, will not get much into it. And then you have a relational operators, right? So basically, what are the relational operators? For example, in Java, you have equal to, double equals, and then not equals, and then greater than, less than, greater than or equal to, and then less than or equal to. These are called relational operators in Java. Okay, so when I say relational operators, they basically determine relationship between one operand and another operand. Okay, so when I say operand, like if you see this statement, C equal to plus plus B, here C and B are operands. Okay, so like say for example, here I'll take example of this relational operator, right? Is A equal to B? Okay, I'm just trying to use that operator here. Okay, A equal to B. Is A equal to B in this scenario? What is it, guys? Is A equal to B?
No.
No.
No, right? But Java doesn't know no. It knows true or false. So what will be the output?
False.
False. Okay. So this will be false, right? And then is A greater than or equal to B? This is also false.
False.
A less than or equal to B? A is less than B, but not
True.
equal to B, but it will be true, right? A less than B, true, right? So that's what the relational operators are for. Okay, these are the relational operators. So they basically define the relationship between two operands. Here A and B are the operands. So they are defining the relationship between them. And the outcome of these operations is what? True or false, which is basically Java Boolean data type, right? So your relational operators result into the Boolean value. Okay. So basically, how this relational operators are useful, we'll just see in a brief moment when we talk about conditions and loops. Okay. And then you have a Boolean logical operators. So which is nothing but the if you remember. The Boolean logical operators, they only operate on Boolean operands. Okay, so when I say Boolean operands, they only operate on some, like, say for example, Boolean operands, right? So you need to take the Booleans, like Boolean, Boolean, Boolean A, and A, B, C. Closing this. So if you say C equal to A or B, just print C here. I'll say here A equal to true, B equal to false, right? So this is the OR, Boolean logical OR operator. I'm using the OR operator. So how this Boolean logical operator works? If you see OR is there, AND is there, this is XOR operator, exclusive OR, and then you have not A, which is the complement, right? So if you look at this, how the values will become, what will be the values is, if you see A is false, B is false, A or B is false, right? But A and B is also false, A or B is also false, not A, which is basically complement of this. This is false, this will not A will become true automatically, right? And similarly, this is called the truth table. So if you these Boolean logical operators will follow this truth table logic. Okay. And if you see A here, it is true, B is false. So now A or B will be true, but A and B will be false always. So this will execute as per this particular truth table. So basically OR is, if you have two operands, one of them is true, then eventually your A or B will become true. If both are false, then A or B will be false. So if you look at here, A is false, B is false, it's false. Otherwise, if A is true, B is false, it's true. A is false, B is true, it's true. A is true, B is true, it is true. In case of AND, if both are true, then only it will be true. Either it will be false always. Okay, if one of them is true or both are false, it will be A and B will work as false. So this is how this Boolean logical operator works. Okay, so if you see here, you have true and you have false, right? What is A or B? A or B, which we assign to C, this will become true. Okay, A or B, that means one of them evaluating to true is fine for us, right? So this is what it is. This is the bit logic. It is called bit logic truth table. Okay, which is if you are a mathematics student, computer student in graduation, like you would find this particular table where we would be discussing about this, right? So yeah, I think that's all, guys. Any questions on the operators front? I think that's all with respect to operators. Any questions here? And operator precedence, we already discussed it, right? How the operator precedence will affect the mathematical expressions. So the one key thing you need to remember when we speak about operators, right? So for you, this arithmetical, relational, and the Boolean operators are quite important. Okay, the bitwise operators, you rarely work with them. And you should also understand operator precedence. So it's a best practice whenever you write any mathematical expression, you know which should execute get first, right? So as per the Bodmer's rule. So just try to put the parenthesis around it. So that will clearly avoid the confusion on what kind of output that particular mathematical expression will evaluate to. Okay. Any questions here? We'll stop here for today, guys. Okay, I want you to just go back and look at these operators once again, and probably try. I want you guys to go back and explore bitwise operators more, right? Like left shift, right shift, which we discussed, right? And try to. I hope you guys understood the difference between the prefix and postfix operators clearly. If not, just look at it again, and if still not clear, come back to me with some questions tomorrow, right? And then relational operators, there are very few which basically define the relationship between two operands, right? And the resultant is a Boolean value. So that's all, guys, with respect to operators. So we'll discuss the rest in tomorrow's class. Any questions? I'll take some questions if you have.
Oh yeah, I have a question.
Yes, go on.
So the